Hello, this is Mrs. Mitchner, and today we're going to be working on section 9.5, and today we're going to be working on in section 9.5 alternating series and finding convergence, either absolutely or conditionally, absolute or conditional convergence. So basically today we're going to be working in section 9.5 with the alternate series test. Alternating series test. So let's look at an alternating series. If you look at the box on your notes, you have an alternating series, and the reason why you know it's alternating is that right there. You have -1 to the n minus 1, or you can have -1 to the nth. So as you plug in n, increasing from 1 to infinity, the terms will actually alternate from positive to negative, and so on and so forth. Now, an alternating series is going to converge if the following is true. Letter I right here. If your next term, this a sub n plus 1, is representing the next term, if the next term in your series is less than the previous term. So basically the series is non-increasing, and the limit of the nth term has to be equal to 0. Notice this condition itself is not sufficient to determine convergence, just this part right here. You have to have both of those to be true. So I'm going to look at example 1. Looking at example 1, it says to determine the convergence or divergence of the following. So I look at this and I think, okay, it's alternating right there, it tells me that. So what I'm going to do then is I'm going to say, well, my a sub n is equal to my 1 over 3n, and my next term is found just by plugging in n plus 1 for n. So I get 1 over 3 times the quantity n plus 1. I got a pen that looks kind of strange here. Okay, so now I want to test and see if I can actually find out if it's converging or not. So I just write this out. Is my next term 1 over 3n plus 1, is that less than my 1 over 3n? Well, I know that my denominator right here is larger. So yes, it is in fact a smaller number than 1 over 3n. Now another way you can find that out is to find the derivative of a sub n and see if it's decreasing. So if you're not really able to check just by looking at your fractions, you can always do the derivative of your a sub n and show that it's decreasing. The other thing I want to just kind of state is, does the limit as n goes to infinity of 1 over 3n, is that equal to 0? Well, if I plug in infinity in for n, I get 1 over a very large number. So yes, that is correct. So therefore, I can say that the summation as n goes from 1 to infinity of -1 to the n plus 1 all over 3n converges by the alternating series test. I will always be telling you what test I'm using so we can kind of just get used to identifying what we have and what did we use to find out if the series was converging or not. Okay, so what I'd like for you to do, I just gave you one example, but I would like for you to try number 2 with your study buddy or people around. So put the video on pause, and then when you are done, you can turn the video back on, and I want to see how you did for number 2. Okay, so hopefully you've had time to work on number 2. So here's what I did. First of all, when I have -3 raised to the n minus 1 power, I like isolating that alternating term. So I'll rewrite that as -1 to the n minus 1 in the denominator times 3 to the n minus 1. So then when I look at what is a sub n, I let a sub n be my n over 3 raised to the n minus 1 power. And my next term would be n plus 1 over 3 to the n plus 1 minus 1, which reduces down to 3 to the nth power. Now the question is, in fact, is the next term less than the previous term? And the answer is yes, because when I have 3 to the n, that's going to be larger in the denominator than 3 to the n plus 3 to the n minus 1. So I know that that is going to, the fraction on the left will be less than the fraction on the right. So then what I did next is I found my limit of n over 3 to the n minus 1, and I found that that would actually give me infinity over infinity. So I applied L'Hopital's rule, and I got 1 over 3 to the n minus 1 times the natural log of 3 in the denominator, which does go to 0. So by the alternating series test, I know that that original series will converge. Okay, looking at number 3. So if I look at number 3, I would say, okay, ignoring the alternating term, I see it's alternating. I am going to look at this and say a sub n is going to be equal to my 3 to the n, or 3n, I'm sorry, all over natural log of 4n. And I also have my next term that would be equal to 3 times the quantity n plus 1 all over natural log of 4 times the quantity n plus 1. So that would be 4n plus 4. So those are my two terms I'm going to look at. So now I'm going to look for the first part. Is my 3 over n plus 1, is that going to be greater than 3n over natural log of 4n? And this is one that's maybe not as obvious to look at. And remember, what we're testing here is we're looking to see, is the series, looking up in the box at the top of the notes, is the series non-increasing? So sometimes, I don't know, looking at this, if you can figure that out, that's great. But sometimes we need another tool. So I'm going to just add a page here and go over and just say, I want to try something else. I want to look at f of x, which was my just my, or my a sub n, 3x, I'm going to put it in terms of x though, of natural log of 4x. Okay, I want to find the derivative of that. So doing my quotient rule, my low d high minus high d low, I would get 3 times the natural log of my 4x minus high, low, see, low d high minus high d low. Okay, sorry about that. I had to put on pause here for a minute. Okay, so I have, where was I at? Let me start again. Lost my train of thought. So I'm doing the quotient rule. So I have low d high, so the high derivative is 3 times the natural log of 4x minus high d low, so I get 1 over 4x times the derivative of the 4x, which is 4, all over low squared. Okay, so looking at this right here and reducing a little bit, I am going to see the x's cancel here and the 4's cancel there. So what I have left then is 3 natural log of 4x minus 3 all over the natural log of 4x quantity squared. Now, I want to know, when is my derivative equal to 0? Because I need to find the critical numbers. Wow, we haven't done that for a long time. Critical numbers. So I'm going to let my 3 ln of 4x minus 3 equal to 0. So let's move that 3 to the other side. So I get ln of 4x equal to 1. So basically now switch it to exponential form. E to the first is equal to 4x, so x is going to be e over 4. Now you might need a calculator to figure out what e over 4 is, and remember we have to plug this into our derivative. To save us a little time, here's my e over 4. I found it to be negative and then positive, which right here, my function is going to be increasing after e over 4. So that's kind of telling me that my next term is not necessarily smaller than my previous term. So if I go back then to this previous problem, let me show you something else. So that's really not true, so we'll just kind of put an X through that. And say maybe you want to look at the second part. II, where you would take the limit as n goes to infinity of 3n over natural log of 4n. And what we get is infinity over infinity. So we would have to do L'Hopital's rule. So I have the limit as n goes to infinity of 3 over 1 over 4n times 4 gives me just a, whoops, yeah, that's correct, just gives me a 3n. Well, if I plug in infinity for n, I just get infinity. Well, remember that that was supposed to go to 0. So therefore, in this example, we know that the series will diverge by, basically we did the nth term test. Okay, boom, right there. The limit of the nth term is not a finite number. Okay, or does not go to 0, I should say. Alrighty, so that is example 3. Why don't you try example 4 with your study buddy, and I'll put the video on pause and you can come back and check your answer. Okay, so you've had time now to work with your partners with number 4. So looking at this, here's my a sub n, that's my 2n plus 3 over 3n squared minus 4, and my a sub n plus 1, I just plugged in n plus 1 into my a sub n. Yes, the next term is less than the previous term. And the limit as I applied n going to infinity, I had to use L'Hopital's because I got infinity over infinity. I applied L'Hopital's, I got 2 over 6n, which would go to 0. So yes, number 4 converges by the alternate series test. Okay. Now, the next one, my alternating series remainder, that box there at the bottom is telling us that if a convergent alternating series satisfies the condition at which the next term is less than the previous term, then the absolute value of the remainder involved in approximating the sum s by the sum of the first few terms is less than or equal to the first neglected term. That is, my remainder, which is really the absolute value of my series minus my sum of the first partial sums, is less than or equal to the next term. Okay, that's also called our maximum error. So next page. Looking at number 5. Looking at number 5 here then, it asks me to approximate the sum of the following series by finding its first 4 terms. Okay, so I look at this and I would have the sum of the first 4 terms. Let's write those out. If I plug in my first term, I would just get 1. The second term, plugging in a 2, that would be a 2 factorial, so I would get 2 factorial is just 2. And 2 plus 1 is 3, so my sign is not actually positive. It would be negative 1/2. Plugging in I plugged in 1, 2, 3. I would get 3 factorial is a 6. My exponent of the negative 1 is now positive, so it's positive 1/6. And the next term is negative 1 over 24. So if I were to add those first 4 terms together, I would just get 15 over 24. And that's all this problem is actually asking me to do. But let's go ahead and do one more step. Let's find out what that remainder would actually be. Okay, my remainder has to be less than the next term. So if I think about this, my remainder, which is really my absolute value of the sum of the series minus the sum of the first partial terms, would have to be less than or equal to my next term. My next term in this example would be whatever my a sub 5 would be. So if I look here, my sum of the series, which I'm not going to write all that down, minus my 15 over 24, has to be less than or equal to, so if I plug in 5 there, we all remember that 5 factorial is 120, and that would be a positive term, so that would have to be less than 1 over 120. Okay, so that's kind of like my error. If I wanted to find my range for the value, so I would have my range would actually be my S sub n. Think about this right here. Let's go back to maybe, I don't know, algebra 1, where if you have an absolute value, isn't that the same as saying, well, my negative 1 over 120 is less than or equal to my S minus my 15 over 24, which is less than or equal to my positive 1 over 120? So that's basically my range. So if I add my 15 over 24 to all three sides, I would get 15 over 24 minus 1 over 120 is less than or equal to my series, which is less than or equal to my 15 over 24 plus my 1 over 120. So I can actually find out my range if I am asked that. Okay, so that is my range, and I'm not going to take the time to throw that in my calculator right now, but if you're curious about that, you can. But there's my range for my series. Okay, moving on to number 6. Let's look and see what we have here. Definition of absolute and conditional convergence. If I look at this, I have the summation of a sub n is absolutely convergent if the summation of the absolute value of a sub n converges. It'll be conditionally convergent if the summation of a sub n converges, but the absolute value of that series diverges. So if I look at this, I would probably go ahead and do my absolute value of my series first all the time. Okay, so let's look at number 6. Determine whether each of the following series is convergent or divergent and classify each convergent series as absolutely or conditional. Okay, looking at number 6. I got to look somewhere else because that's really hard for me to read right there. It's kind of blurry. I have the summation of negative 1 raised to the n times n plus 1 divided by 2 times 1 over 3 to the nth. If I want to actually, wow, it kind of looks like an alternating series just because I have negative 1, but I've got that n times quantity n plus 1 over 2, so maybe I need to look a little bit closer. And if that's the case, I'm going to actually write out my terms. What is the first, I don't know, let's do the first 4 or 5 terms. I get the first term is actually negative 1/3. The next term is negative 1/9. Then I have 1 over 27. And then I have a positive 1 over 81. And that's probably enough to see that's not necessarily alternating. Not in like positive, negative, positive, negative. Look what I wrote, alternation. I've got to pay attention to what I'm writing here. There you go. This is not necessarily alternating, so I'm going to look at just the absolute value of my series. And if I look at that, the negative 1 to the whatever power, I really can ignore. So basically I have the absolute value of 1 over 3 to the n, which is just 1 over 3 to the n. Now hopefully you recognize that this is what type of a series? Geometric, where my r is equal to 1/3, which is less than 1. And we all know that when we have a geometric series and the r is less than 1, that it is going to converge. So since we did the absolute value of that series, we know that it's absolutely converging. Okay. Absolutely converging is just a very strong type of convergence. Okay. Now, what I'd like for you to do is why don't you give example 7 a try with your group, and then you can come back and check your answer. Okay, so here we go, finishing up number 7. So what I would do first of all is do my absolute value, and I see that this series is going to be like 1 over n plus, no, 1 over the natural log of 2 plus 1 over the natural log of 3 plus 1 over the natural log of 4 and so forth. So if I look at that one, I would say, okay, I'm going to do a direct comparison test to that. So I'm going to compare that to 1 over n. So I have 1 over a sub n to be 1 over the natural log of n plus 1. My b sub n is going to be 1 over n. Now keep in mind that 1 over n is a p-series where p is equal to 1. More specifically, it's called harmonic, and that is going to diverge. So if I look at this, I have to compare and see which one's larger, 1 over n or 1 over the natural log of n plus 1. So I'm looking at the denominators only. We all know the graph of just n, like y equal x. And then I have a natural log graph, which I graphed in black. So if you look at those, which one's growing faster? Well, then the n is going to be larger than my natural log of n plus 1. So basically the left side of that inequality, 1 over n, is in fact less than 1 over n plus 1. So then going back to our previous day's lesson by the direct comparison test, if the smaller series will diverge, then the larger series will also diverge. Okay, so since I have the absolute value diverging, I'm going to go back and look at just my series without the absolute value. Well, it is alternating, isn't it? So I'm going to let a sub n be equal to 1 over the natural log of n plus 1, and b sub n be being 1 over the natural log of n plus 2, which is the next term. I do know that the next term is less than the previous term, and I also know that the limit as n goes to infinity of 1 over the natural log of n plus 1 is equal to 0. So by the alternating series test, I know it's going to converge. So overall, what's happening on this series? This is a conditional convergent series. Alrighty. So now I'm going to go to number 8. Looking at number 8, I'm going to once again look at the absolute value of this. Let me get rid of that one. Okay. The absolute value of this series will look like the summation of the absolute value of negative 1 to the nth all over the square root of n. And when I take the absolute value of that alternating part is just going to fall out. So I get 1 over the square root of n. Well, we all know what that is. That's a p-series where p is less than 1, so it's going to diverge. Okay? So what I'm going to do next then is I'm going to look at the summation of negative 1 to the nth all over the square root of n. And that is alternating. So comparing this, I would have a sub n be equal to my 1 over radical n. My a sub n plus 1 would be equal to 1 over my square root of n plus 1. So my next term is 1 over the square root of n plus 1. And I got to look at first test. Is the next term less than 1 over square root of n? And the answer is yes. So in the second part, is the limit as n goes to infinity of 1 over square root of n, is that equal to 0? And the answer is yes. So now I can say here that let me get my pen back here. Whoops. It's not what I wanted. I can say that this is going to converge by the alternating series test. So if I look back, we had the absolute value diverging, and we went back and we saw that without the absolute value using the alternating series tests, that my series is going to converge. So we could say, therefore, my series in going from 1 to infinity of -1 to the nth, all over square root of n, conditionally converges. Forgot my y there. There we go. That is number 8. Now, going back here, I noticed in number 7 that I did B sub n right here. I don't know if that confuses you or not, but when I'm looking at this right here, I wrote a B sub n right there, which is actually my A sub n plus 1, which I did not match up with that down there. So if I confused you on that, I'm sorry. I can go back and erase that if I can erase just a little bit and fix that. Why do those numbers keep coming up? A sub n plus 1. There we go. Now they match up. Alrighty. Well, if you want to do number 9 together, you can. And don't take very long because we've still got another section of notes. And you can work on that together, or you could just check and see what the answer is and work it later to help you practice for a quiz or a test. I'll just give you this answer so you can check it later. This is going to absolutely converge. Okay, that's the final answer for number 9. Absolutely convergent. So use that to study for later, or if you want to check with me when I get back if you did not get that answer. Okay, we're at the end of section 9.5. So have a good one.